Welcome to another episode on how to build your own supercomputer. And in this episode, I'm going to show you how to perform a multi-flash. In short, how to flash multiple nodes in one go. Now, the most important thing here is automation. So I'm going to introduce to you one of my personal phrases I have been saying for years. Laziness is art. Intrigued? Keep watching. I'm Garrett, and this is TimmerTech. In this video, we're going to talk about a few things. We're going to talk about automation and the phrase I introduced earlier, laziness is art. I'm going to show you how to grab the Ansible TPI project to automate your tasks, and I'm going to show you how to perform a multi-flash. Now, here are some timestamps for those who cannot wait and want to jump ahead. Now, let's dive in. Let's talk automation. So automation is vital. Take me, for example, right? I have a lot of IT and tech stuff to take care of, which takes time and effort. But there's only me, which means it comes all from my time. And I do not have employees to take care of stuff and to do tasks to get things done. There's only me. Now that's the important key here. It is all about time. Now, let me give you an example. No matter how many millions or billions you have in your bank account, there's one thing you cannot buy. And that is hour number 25 in one day. No matter how much money you have, you cannot buy it. Yes, you can spend money to pay other people to do things for you and therefore reclaim time, but you cannot actually buy time. And that is the most important thing to understand about automation. You cannot buy time. Now let's go to the phrase, laziness is art. I designed that phrase deliberately the way it is art. It does not mean it's good to be lazy or anything relating or something like that. No. It means that you understand that when it comes to automation, it is important how you use your time. And when you have to do repetitive tasks, it's more important before you start doing anything to think about a problem. Basically, before you do anything, you ask yourself, do I need to do this more often? And if I do this more often, or even incidental, how much time will it cost me? Time is something you can actually spend. You cannot buy it, but you can spend it. So what you can do, you can spend time and energy in the beginning of something to reap benefits later. And that is the whole key of automation. You spend a lot of time and energy on automate something so that over time it takes less effort, less energy, and you're basically allowed to be a little lazy. And that's the key. If you do this right, then laziness is art. Now, with that out of the way, let's get started on our multi-flash. So, what I've done is I created an Ansible TPI project. And it's actually based on my Ansible template. You can find the videos about what is Ansible and my Ansible template down below. And here's the thing. This template and this Ansible project is designed specifically for the Turing PI. Even if you don't have a Turing PI, look at it. See how I'm automating tasks. Because the thing is, with the right setup, you can quickly accomplish something. And in the meantime, enjoy a cup of coffee. And that's what we're gonna do. So first, let's grab our Ansible project to get started. So to grab our Ansible project for Turing PI, head over to github.com/ggrtimmer/Ansible-TPI. And there you find my entire Ansible Turing PI project, which will grow over time. So the more I make these videos, the more modules I'll put in for more and more tasks to be automated so that everybody can enjoy it. The whole thing, what I'm trying to accomplish here, is to set up a solid foundation, which takes a lot of time and effort. And that's what I talked about earlier. It takes a lot of time and effort to set this up and to build this. The benefit is, if there's anything goes wrong in the future with any of the nodes in the Turing PI, I can either pop in a new disk or reset everything, type a few commands, go drink coffee, enjoy doing something else, and a few moments later, everything is back up and running as it should be. And that's what we're starting with today. And the first step, what we're gonna do is we need to flash multiple nodes. Now, let's head over to GitHub and grab our project. So, and magically, here we are. Now, this is the best part. This is the Ansible TPI project. Currently, there are only two roles and two playbooks added to this, which is to install the Turing PI client, either local and on any target node, but also the flash module to simply flash multiple nodes. So let's grab this by getting the Git URL. Now let's pop over to our terminal and clone our project. And here we are. Oh my God, that was fast. So git clone, project URL, and here we go. And that's it. Now we have a project and we're basically almost ready to get started. Now, so you know, this project is based on my Ansible template project, which is a project that has a full Ansible dev container up and running, so you can quickly get started without have to deal with installing Ansible, dependencies or anything. I strongly recommend to jump over to that video to watch that about all the goodies that are included. Just remember, you need Docker and VS Code to use it with the dev container, which I'm gonna do because it allows me to get started in a few seconds. Let's pop over to Visual Studio Code and open our project. Now in Visual Studio Code, we're gonna say open folder and we're gonna go to Turing PI and there Turing Ansible TPI, and we're gonna open the project. And as you can see at the bottom right here, it shows, hey, I detected the dev container. Do you want to start it? Well, yes, we want to get started on this as fast and simple as possible. So I'm going to open this, reopening container, and I'm going to choose the standard TPI container because in this scenario, we do not need the playground activated. If you want to know more about it, again, watch my video about my Ansible template. So let's open this. It should take only a few seconds. And there we are. Now, fresh new project. And as you can see, it's actually installing the extensions for this repository so that everything works out of the box. And enter to put focus in the terminal and enter to finalize everything. So now we're set up, we're ready to go. At this moment, we could actually already start flashing nodes. Before we do that, there's one thing you need to do, which is you need to update your inventory. So this repository comes with a standard configured repository for most standard scenarios. However, you might want to change it to represent your own environment, your own servers, or your own Turing PI configuration. You do that by modifying the hosts.yaml file. And in this case, the default, hey, I build it, I get that luxury. It represents my setup. So I do have multiple Turing PIs, but in this case, I'm only targeting one, the new 2.5 Turing PI. So we have one BMC and with the standard username password, and I defined 4 nodes linked to that BMC. There are comments in the file to explain how to do this and how to do multiple TPIs, but that's for now not needed. I have 4 slots, all filled with a RK1, and I'm also going to use NVMe drives for fast storage. Now, in later episodes, I'm going to show you how to bootstrap these nodes, how to transfer the file system to the NVMe drive, and to get everything up and running. But for now, this is my standard configuration. I have 4 nodes set up for the future with NVMe drives. Now, the best part is this project, when it comes to flashing, already supports both the RK1 and it supports the Raspberry Pi Compute Module 4. Now, after you made your changes to your host file, we're ready to go actually. Let's get started on our multi-flash. Now, before we're gonna flash, I'm quickly gonna run you through the role I designed for this. Before we get started, I'm quickly gonna run you through the role of the flash, the Ansible module. Now, before we get started, I'm quickly gonna run you through the flash process. Before we get started, I'm quickly gonna run you through the process of flashing I designed. Within the folder roles, you will find the roles of this project. And the best part is each one comes with documentation. I know a lot of IT guys do not like documentation. However, over the course of time, sometimes investing time in the beginning on a little bit documentation can help you a long way. For example, after a few months, you might lost the specific details. What was this command? What do I need to do? So sometimes having a little bit documentation can go a great way. Now, when it comes to the flashing process, I am quickly going to open this in the preview. Everything is set up and the flash process requires the installation of the TPI on your local machine. It's also taken care of. It will automatically update and install the TPI client. Furthermore, I designed this process in combination with the SD card of the BMC, which means it will download the OS required for your specific module, which you have defined in the host file, where you say, hey, this type is an RK1 and this type is a Raspberry Pi Compute Module 4. So it will select and download the correct OS image. It will then transfer it to the SD card on the BMC, and then it will go through flashing the modules one by one, by one, and by one. And then we're done. You can make modifications to it. You can give variables to give the command in certain ways to ensure that it represents your configuration. Everything that you could be needing should be there. If not, please let me know. And together we can build and extend more amazing options to this module. Now, also you have full-on examples here if you have multiple BMCs. So here's where you can find that. But basically what we're gonna do is we're gonna target all 4 nodes and we're gonna give the option to flash them. by default, I turned that off. So you have to deliberately give the command, I want to flash this node. Let's get started. Now, because we are using a dev container, everything just works out of the box. What we're going to do is, before we can flash, we need to make sure the TPI client is installed, because the process uses the TPI client to connect and to flash the nodes. So we need to install that first, because we just started a brand new fresh development container and there's no TPI command. So as you can see, command not found. I have a different video about how to install the TPI command, but this project actually comes with a quick and easy way to install. So what we're going to do is we're going to say, hey, Ansible playbook, and let's target localhost, because hey, that's this development container. And we're going to say playbook, and we got here the TPI CLI, and that will install the TPI client in this development container. And that's it. That was how simple and easy it is to install a TPI client in the development container. So let's clear the screen and get ready to flash our nodes. Now, to flash the nodes, it's very simple. We're gonna run the playbook flash nodes. So we're gonna start with Ansible -playbook, and we're gonna give it the option -L for limit and nodes. Now, nodes is the group defined in our inventory in hosts.yaml. And that's to ensure we do not accidentally try to flash Ubuntu server to the BMC itself. Okay, now if you run the playbook without any options, nothing happens. So we need to explicitly tell that it is okay to flash. And we do that by giving -e for environment variable. And we're gonna say flash underscore node equals true. And then we finally have to give it the playbook, which is flash-nodes. Now, before I'm gonna hit enter and flash the nodes, something important you need to know. And that is, in the beginning of the process, the playbook will ask for the password of the BMC multiple times. And it connects to the BMC with the host or IP address defined in the inventory in host.yaml. And what it's gonna do is that by default, this playbook is designed to work with a SD card in the BMC. Now, if you do not have an SD card, don't worry. In the documentation, you can turn that feature off and it will flash the image from your laptop to each node. Now, when it is on by default, it will assume an SD card is present. It will check the SD card if the image is on the BMC SD card. If not, it will download it and copy it over to the BMC SD card. Now, because that is currently not the case, it will check first, see it's not there, and then it will download and copy it over. So it will ask me for my BMC password twice, after which the entire process will run automatically. So, flash our nodes. Here we go. It's gonna check for the status and to make sure the node is off. And as you can see, it requests check image on BMC. Well, we're gonna give it the BMC password, and it did not find the image, so now it is downloading the image. Give this a few seconds, and then it's gonna ask me again for the BMC password to copy over the image to the BMC, and afterwards it will run automatically, and I will see you in a few minutes after the flashing process of all the nodes is done. So it will now say copy image to BMC SD card. Yes, here's my password. And now it's copying. So the entire process will now run automatically, and I see you in a few minutes when all the nodes are flashed. And we're back. And as you can see, everything went perfect. This is how you do a multi-flash. So in this episode, we talked about automation, one of my personal favorite quotes, and we completed a multi-flash. of all our nodes in our Turing PI. If you enjoyed this video, like, comment below, and I see you guys in the next video. I'm Garrett, and this is TimberTech.